The rest of the notes in there, because I only have the ones that I pulled.
Okay, so today we're talking about conditional probability. Okay, it's usually when we're given a big chart like this, okay, and we need to limit our sample space for an event. So instead of looking at the whole chart, we're only going to look at a specific part of the chart. Okay, conditional probability is the probability of A with the little line B. And it's read the probability of event A given event B. The formula for this is written. The probability of A and B over the probability of B, where the probability of B cannot equal 0 because you can't divide by 0.
Does that line mean the equation?
Means given that. Given that. Okay, intersection is of two sets is the set of elements that belong to both sets. Okay, an example, the probability of me choosing a student from my class that is a junior and 16 years old. Okay, notated the probability of junior and 16. There's only one person who is both. Only a person who's both. Okay, so I'm only choosing one person this time instead of choosing two people. Because sometimes we'd see that and or that intersection and there'd be two events occurring. This is just one. And I want them to meet both criteria. Does that make sense? Okay. So hopefully, guys, we added up a bunch of these. Let's see. Okay, so this should be 210. Ooh. And this is 233. Then 184. Then 139. Then we had to add down as well, you guys. Did anyone add down for me? Okay. So then this was 135. 182. 210. 239. Okay, did anyone add the totals? Okay, good. So then the total of totals is 766. Okay, this number is everyone I surveyed. I surveyed 766 people. Okay. Now, we're relating being depressed with being on social media. Okay, and we're seeing if there's a correlation between the two. Am I more depressed if I spend less time on social media? Or am I more depressed if I spend more time on social media? Okay, so that's what it's kind of trying to relate. So the first thing is I want to, out of everybody I surveyed, what's the probability of me picking a random person that is mildly depressed? Okay, so that's 766 people I surveyed. Very good. And of the people I surveyed, 233 said they were mildly depressed. So that gives me 0.304. The 4 does not make me round up. I move my decimal over twice and I get 30%. So 30% of the people I surveyed or I talked to said they were mildly depressed. Okay, then the next one is what's the probability of me choosing a random person that spends 31 to 60 minutes on social media? a day. Okay, so very good. I'm still working with everybody, 766. And then I just go to that column. That's this column right here. And there's 210 people. And that gives me 0.274. The 4 does not make the 7 move up. So I move my decimal over and I get 27%. Any questions over that? Okay, so that's just basic probability. Me choosing somebody that meets one criteria. Now I want two things to occur. Okay, I'm still choosing somebody out of everybody in my group. Probability of no social media and severely depressed. Okay, so I do 766 is that. Then I went the people who are no social media. So no social media, these people right here. And severely depressed would be these people here. Okay, I want that intersection. These people here, where those two meet. Okay, so that's 8 people. Okay, the 0 does not make the 1 move up, so it gives me 1%. Any questions over that? Okay, you do D. Okay, Danny, what'd you get? Very good. There were 26 people who were both no social media, or sorry, what was it? Mine's different than yours. Not depressed, so it's these people, and then over 60 minutes. So that's 26 people. And what percentage class was that? 3%. Any questions on how I got that? Mine doesn't say the same thing that yours says, right? Okay, next one is moderately depressed. Now this is given that 31 to 60 minutes. Okay, so this second thing, I'm only looking at these people. Okay, remember the given that or the conditional probability means I'm narrowing it down to a smaller group of people. So I'm no longer looking at all 766 people. I'm only looking at these people. Okay, so I'm going to go to that wonderful column 31 to 60. And I'm only going to look at these people now. So how many people are in that group? 210. So now, the denominator now is different. It's 210 people now. Now, in that group, how many people are moderately depressed? Very good. So I looked at the people who are moderately depressed are these people. So it's going to be 64 on top. Okay, does the 4 make the 0 move up? Okay, I move my decimal over twice, so it's 30%. Any questions over that? Okay, do the next one. Okay, Steven, what did you get your fraction to be? Shh, very good. So again, we're only looking at the moderately depressed people. Okay, so that's this group of people here. So that's 184 people, and of those 184 people, 64 of them were on social media from 31 to 60 minutes. Okay, any questions over that? Okay, so then that gave me what percentage, class? 35%. We're good. Okay, now I'm giving you guys a chart that's not completely filled in. Okay, and we have to fill it in. So this is pretty easy. This plus this will give me this number. So this is 303. And then this plus this will equal this bottom number. Then I can add these. This plus this will equal this. Is it 698? Okay, then I need to get this number here. Okay, so this plus what number will give me this? So I just subtract them. This is 139. And then this plus this will give me this number here. And then these two should also add to 698. Any questions over that? We're all good? Okay, so this is a survey for students and parents where they were asked if they would like school to start an hour later and end an hour later. Here is the partial information from the survey. Complete the chart and calculate the probabilities. Okay. So we want, again, this is a given that, so only look at students. Okay, so I don't care about anybody else. Okay, so I'm only going to look at those students. So that's 303 people I talked to who were students, who identified as students. Okay, and of those people, how many of them said yes? The 187. So what percentage of students wanted to start later? So it's 0.617. The 7 makes the 1 move up, and I move my decimal over twice, and I get 62%. You guys do H now. Thank you. Okay, who got H? What was our fraction for H? Okay. Shh. Quiet, please. Brianna's going to do it. 139 over, what was on top? Oh, sorry, 139 was on top. Sorry, I missed it. 139 over 395. And what percent did you get? 35%. Very good, because I'm only looking at the parents, so the total number of parents is 395. And of those parents who said yes, 139 of them said yes. Okay, the next one is just going back to basic probability. Adam, what did you get for this one? You didn't get it? Okay.
No, sorry.
Nate, did you get it?
Yeah.
What did you get as your fraction? 6 over 698. And then did you get the percent? Okay. Yes. Can you wait until we're done? Okay. Fill out a pass. Okay. Maddie, what'd you get for J? And what percent was that? 68%. Any questions over that? Shh. Okay, now this is the tricky one. Okay, reading a Venn diagram and creating it and putting it into a table, basically. Okay, when you look at your Venn diagram, you have to find two things, okay? So this Venn diagram says, are you male or female? And then, which do you prefer, vanilla ice cream or chocolate ice cream? Now, where you put the vanilla and chocolate and the male and female in the table doesn't matter. Okay. You can put the male and female here, or you can put male and female here. You can put chocolate vanilla here or here. Doesn't matter. Okay, so I'm just going to do this as male. This is female. This is chocolate. This is vanilla. Okay, the easiest one to start with is this middle. Start here. Okay, I have a circle that is chocolate and I have a circle that is male. So these people, okay, are males who like chocolate ice cream. Does that make sense? So this is 96 and it goes right here. That leads us to these people here. They are only in the male circle, so they are only male. They don't like chocolate, so what is their option? Vanilla. So these people are only in the male, and so they like vanilla ice cream. Okay, these people now are only in the chocolate. They are not male, okay? So these are female chocolate. This is vanilla. Okay, then this group of people are not male, so they are female, and they are not chocolate, so they are vanilla. Okay, so they're vanilla and female. Okay, So that's hard to read, but part of our standards are that we are able to read a Venn diagram and create a table from that information. Once we're there, we're going to add up everything. So add up all those numbers for me. Okay, did I get my numbers correctly? Do you guys agree with my numbers?
Yes.
Okay. So now we're going to answer some questions. Okay, female given the chocolate. So we're only going to look at the people who answered chocolate. So that's these people here. So that's 181. Of those people who like chocolate, we care about the people who like who are female. So that's 85. That's 0.469. The 9 will make the 6 move up. So I move my decimal over twice, and I get 47%. Any questions over that? Okay, next one. You guys do that one on your own. Okay, Jenny, what'd you get for yours? A 121? Oh, male, so here, you're right. Sorry, I was getting just vanilla. 152. There are 152 males, so we're only going to look at that row. And of them, we want to only look at the people who chose vanilla as their favorite ice cream. And so what percent did you get? 37%? Any questions over that? You need to move back to your seat. Okay, this one is female or vanilla. Okay, so we're still going to look at everybody. This time we're going to look at everybody and not just limit it. So 302 is everybody. Okay, this is the tricky one. We want female or vanilla. Okay. So that's going to be 121 plus 150. However, who is getting counted twice here? Which group of people are getting counted twice? Or what number is being counted twice? The 65. Okay, 65 is included in female and it's included in vanilla. So this 65 is counted twice. So you have to subtract the overlap. Okay. Okay, so you're going to subtract the number that is in both. If you do not subtract that, then your answer will be wrong. So that's going to give me 121 plus 150 minus a 65. So this gives me 206 over 302. That gives me 0.682. I move my decimal over twice. The 2 does not make the 8 move up, so it's 68%. Any questions over that? We're good? Okay, one more page. Okay, so there is another way to organize our data. We've seen a Venn diagram, we've seen the table, and now we're going to see a tree diagram. Okay, a tree diagram is most often used when you're given percentages, when they already tell you percentage of people doing things instead of just numbers of people. Okay, so of this, of all respondents, 17% are male. Okay, so when we have our tree diagram, we usually have two options. So the first thing is male, and 17% of them were male. Okay, our other option is female. So it's 100% minus 17% will give me how many female? So 83% of my respondents were female. Does that make sense? So you're always going to subtract it from 100. Okay. Always assume it's going to be two options. It's not going to have 3 or 4 options because that will get too complicated and you wouldn't make a tree diagram out of it. The next one, it says the male respondents, 33% were left-handed. So we have left-handed would be 33%. And then right would then be 100 minus the 33%, which is 67%. Same with female, we're going to do the same thing. Okay, of female respondents, 90% were right-handed. So 90% was right-handed. And then we have the left-handed people then is 100 minus the 90, which was 10%. Okay, the tree diagram makes it easy for you guys to use the conditional probability because they've already separated it for you and found all that probability. So for this first one, you all get a copy down? So this first one, then find the probability of left-handed given their female. So here's my female. I'm only looking at female now. Okay, so if I'm looking at female, what percent of them are left-handed? 10%. Okay, it's the female and 10%. Now, for this one, it's the probability of male and right-handed. Okay, let's review. And means to multiply. So we're going to find the probability of male. What's the probability of me picking a random person and them being male in my group? That's 17%. So it's 0.17. Then we need to find the probability of that person being right-handed. So what was the probability of the male being right-handed? 67%. So we're going to times that by 0.67. So it's 0.1139. Okay, I move my decimal over twice, and that's going to be 11%. Any questions over that? Okay, so we have time to do our homework, 8.3 homework.